Hello and welcome to MyScience Tutorials. In today's video we are going to be looking at electric field intensity and charge density. Before we begin, if you are new to MyScience Tutorials, kindly consider subscribing and pressing that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics and physics. So let's begin. We want to first of all start by looking at what Coulomb's law says. So according to Coulomb, the law states that what the force of attraction between what two charged bodies is directly proportional to the product of the charges and then inversely proportional to the square of the distance between the points where the charges are situated. So let's have a look at a diagram for that. So assuming we have a charged body, either positive or negative, let me use negative, positive here, and then another charged body which is negative over here. Coulomb is saying the force of attraction between these two bodies, okay, is proportional to what? The product of their individual charges Q1 and then Q2, assuming this one has a charge of what? Q1 and this one has a charge of Q2, okay, and then inversely proportional to the what? To the square of the distance between the 2 points where this charge is located, R. Okay, so this is what Coulomb says, but then we know whenever we introduce a proportionality sign, we need to take it out and introduce a constant. So when we introduce a constant, here becomes what? K, Q1, Q2, all over what? R square. Alright, so according to Coulomb, this is what? How you go around finding the force between what? Two charged bodies. Now, the K over here is given to us by what? 1 over what? 4 pi E naught, where E naught is called what? The permittivity of free space or vacuum. So the E naught is what? The permittivity of what? Free space or vacuum. Alright, so this whole equation, the force, can be rewritten as what? F is equal to what? 1 over 4 pi E naught Q1 Q2 all over what? R square. Okay, now we want to look at what electric field is. Okay, so when we have a charged body, okay, either positive or negative, the area around that charged body becomes what? Its electric field. Okay, and then its electric field is given by the formula or the relationship, the force, okay, divided by what? The charge Q. So now let's have the definition of what the electric field intensity is. So electric field intensity is defined as the what? The force per unit positive charge which the charge exerts at that point. So the force per unit charge as F over Q, which what? The charge body exerts at that particular point. Now let's have a look at this. We know from here, this formula, let's derive an expression for what? Electric field intensity, or E. We know the force over here, we just said, is equal to what? This as we have over here, which is what? K Q1 Q2 divided by what? R square. Okay, so it means from here we can say what? E is equal to what? The K, which is this, K Q1 Q2 divided by what? R square. And then this division sign will now come, or we say multiplication, then 1 over Q. Alright, so if we further simplify this, we get to see that one of the Q can cancel one of the Q over here because they are all charges. Okay, so the relationship for the electric field intensity is K Q1 over what? R square. So it means for the electric field of a particular charge body is just what? The constant K multiplied by the what? The charge on the body over there divided by the what? The square of the distance. Okay, so the relationship between what? Electric field intensity and force is this formula is very important. And we also need to note that we can also write electric field intensity as this, and then we can also write our force to be what? To be this. So this, let this be our equation 1, equation 2, and then equation 3. These three equations are really important, so let's note it or jot it somewhere. All right, let's continue. So we want to talk about the forces that exist, because we just said a force between what? Two charged bodies. Okay, now these forces can either be what? An attracting force or attraction or repulsion, depending on the bodies that are in motion. So let's have, that are having the charge. So let's have an example. If we have a positive charge and then we have another positive charge, okay, these two charged bodies at a point will be what? They will be repelling each other, because what? Like poles what? Repel. So in this case, the force of attraction that this will exert, this one will exert, let me make this one Q1, Q2. The force that what? Q2 will exert on Q1 will be going in the opposite direction. The force that what? Q1 will be exerting on Q2 will also be going in what? The opposite direction. Now the same case is observed when we have both bodies to be what? Negative. Okay, we have the forces being exerted on each other going in the opposite direction, but we have the contrary to this when we have what? One of them to be positive and then one of them to be negative. So Q1 and then Q2. So in a case like this, the forces that we experience is what? We have this, okay, it goes hand in hand. It's the opposite of what we see. So this one, there's a form of what? Attraction between them. So this is supposed to be towards this. Okay, so when we have a positive and then a negative, we have what? An attraction between these two charges, and then the force at hands will be what? Will be greater, instead of what? The repulsion that we experience in the cases of both positive or both negative. So let's look at one final last relation, and then we can start solving example. So we want to look at what charge density is. Charge density. So the charge density of a charge, okay, and it is given by the symbol, this symbol, okay, is defined as what? The charge per unit area. Okay, so the charge density of any particular charged body is just what? The charge, which is Q, over what? The unit area of that particular charge. Now the area, we assume the area to or the body to be what? To be in a spherical form. So the area that it will occupy is given to us by what? 4 pi r square. So it means we can write our charge density as what? Q divided by 4 pi r square. If this holds true, okay, we know that what? Electric field intensity is what? Q divided by 4 pi E naught r square. Okay, so it means if we look at this side, you can say Q is equal to, we can see this, okay, Q 4 pi and then r square over here. So it means if I rewrite this whole thing, okay, let me rewrite the E again. If I rewrite it as what? Q over what? 4 pi r square E naught, we can see that this whole part is what we are saying is the Q over here. Okay, so if that is the case, it means from here we can represent this side by what? The charge density over here, which is this, okay, and then this will be what? Times 1 over what? E naught, because the E naught is still the denominator. So the electric field and then the charge density has this relation. So what? They are inversely proportional. They are directly proportional, sorry. All right, now that let's make this our equation 4. Now that we know the relationship between what? The force and then the charges that are in display, and then we also see the relationship between electric field intensity and then the force, and then we also saw how to relate what? charge density, and then electric field. Let's go ahead and solve some few examples on this topic. Alright, so example number 1. The distance between the centers of two small spheres, each of which carries a charge of what? Plus 1 microfarad, is 1 meter. What force that each exert on the other? And then we are given what? 1 over 4 pi e naught, or the k, to be what? 9 times 10 raised to the power 9. Alright, so let's write our solution. So let's write our parameters first, as always. So the distance between two spheres, okay, two small spheres, of which carries a charge. So we have charge 1, charge 2, and then the distance between them is what? 1 meter. And they both carry the charge of what? So they are both positive. So they have what? Plus 0.1 microfarad. Plus 0.1 microfarad. Okay. Now, because these two bodies are both what? Positive, the force that they will exert on each other is what? The force of what? Repulsion. Alright, so if this is our parameter, then we can go ahead and solve. Now, the force of attraction according to Coulomb is what? 1 over what? 4 pi e naught, or the constant. Then we multiply q1 and q2, that are the charges, and then divided by the square of the distance between them. So the force is equal to 1 over 4 pi e naught is given to us as what? 9.0 times 10 raised to the power 9. Then multiply by the first charge is what? 0.1 times 10 raised to the power minus 6. Micro is what? Times 10 raised to the power minus 6. Multiplied by the second charge is also 0.1 times 10 raised to the power minus 6. Divided by the square of the distance between them. The distance here is 1, so 1 squared. So if we punch this into our calculator, we are going to get the force to be what? 9.0 times 10 raised to the power minus 5 newtons. So this is the force of attraction between these two small spheres that are positively charged, and they are both what? 0.1 microfarad each. Let's have a look at another example. Example number 2. Two coins lie 1.5 meters apart on a table. They carry identical charges. How large is the charge on each if the coin experiences a force of what? 2 Newton. Now this is just slightly different from what we did earlier. So let's first of all write down our solution. Then we write our parameters. So they said two coins lie what? 1.5 meters apart on the table. So our distance r is what? 1.5 meters. They carry identical charges, which means our q1 and then q2 are equal. So how large is the force? How large is the charge on each if the coins experiences a force of what? So we have the force to be what? 2 newtons. So let's write down the relationship between the force and then the charges. So we know F is equal to 1 over 4 pi E naught Q1 Q2 over R square. But then the question is saying they carry identical charges, which means what? Q1 is equal to Q2. And then if this holds true, then we can say what? Q1, and then the Q2 over here can also be what? Q1. And then they are multiplying, so they can become what? Q1 square or Q square. So in place of Q1, Q2, we are going to have F is equal to 1 over 4 pi E naught Q squared all over what? R squared. So we can now substitute all that we have been given in the question, and then we solve for what? Our charge. So our force is 2 is equal to, then our constant is given to us as 9.0 times 10 raised to the power 9 Q squared over the distance is 1.5 all squared. Alright, so let's make let's go ahead. So we have 2, we cross multiply over here, so we have 2 times 1.5 all squared is equal to 9.0 times 10 raised to the power 9 q squared. So we divide q squared will now be what? 2 times 10 times 1.5 all squared divided by what? 9.0 times 10 raised to the power what? 9. So if we punch this into the calculator, we are going to get q squared is equal to what? 5.0 times 10 raised to the power minus 10. So if we find the root of both sides, our charge q, which is on what? One of the coins or both coin, okay, will be given to us by what? 22 times 10 raised to the power what? Minus 6 coulomb. So our charge, okay, q is now equal to what? 22.0 micro coulomb. So that is the charge on each of the coin. All right, let's have a look at one final example where we get to experience how to calculate the field or the electric field intensity midway. All right, so the example number 3 is saying find the force between 2 small charges in the following. Okay, so we have I, negative 1.0 times 10 raised to the power minus 7 coulomb, and then what? Positive 2.0 times 10 raised to the power minus 7 coulomb. Then I 4 times 10 raised to the power minus 7 coulombs, and 3.0 times 10 raised to the power minus 7 coulombs, placed 4 centimeters apart in vacuum. Find in each case the intensity at what? P, midway of the 2 charges. So this is beautiful. So we are having 2 questions to answer for each. So first of all, we have to find the force, and then secondly, we have to find what? The electric field intensity midway between these 2 charges. So let's go ahead and see what we can do. So solution. Okay, so the I, we have negative, and then we have positive. This, and then the distance between them is 4 centimeters. Okay, all right, beautiful. So the first one, because we have positive and negative, it is a force of attraction that is between these 2 bodies. So the positive will be what? Attracted towards the negative. So if the charge between the charge on the negative is 1.0 times 10 raised to the power minus 7, and then the charge on the positive is what? 2.0 times 10 raised to the power minus 7. So first of all, let's find the force between them. So the force F is what? 1 over 4 pi 4 pi E naught, which I've rewritten like that, Q1 Q2 over what? R squared. So our force is equal to 9 times 10 raised to the power 9, then multiplied by 1 times 10 raised to the power minus 7, then what? 2 times 10 raised to the power minus 7, all divided by what? The distance. The distance is in centimeters, so we need to convert it what? Into what? Into meters. So if we do the conversion, we are going to get what? 4.0 times 10 raised to the power minus 2, or 0.04. Then we square it. So if we punch this into our calculator, we are going to get the force to be what? 1.125 times 10 raised to the power what? Negative 1 newtons. So this is the force between, or the attractive force between, the positive and then the negative charge over here. Now let's tackle the electric field intensity part for this one. Now the question is saying what, find in each case the intensity at what P midway of the two charges. So if I redraw everything I have over here, the negative, the positive, and this is our midway, it means here is what, 2 centimeters, and then this is also 2 centimeters, and then this is P, our midway over here, and then we still have the charge on this to be 1 times 10 raised to the power minus 7, and then the charge on this to be 2 times 10 raised to the power what, minus 7. Now we need to take note of the fact that because the electric field over here, okay, because the force or the direction of the arrow over here, the electric field around these two charges are going in the same direction. If we find the electric field of what, the negative at point P, and then we find out of what, the positive at point P, we need to add the two of them to get the overall total what, electric field going around in this case. So let's go ahead and look at that. So let me use E1 for the electric field that the negative is exerting on what, the positive, and then E2 for what the positive is exerting on the negative. So E1, remember we say what, this is equal to what, Q1 over what, 4 pi E naught R squared. This is the relationship between what, the electric field and the force as we saw earlier. So straight ahead we can go and then find our E1, which is equal to what, Q1 is what, 1 times 10 raised to the power minus 7, then our constant, which is 1 over 4 pi E naught, what we have over here, okay, the denominator is or the distance is 2, which is 2 times 10 raised to the power what, minus 2 all squared, and then we multiply it by what, our constant, which is what, 4 pi E naught, so it's 9 times 10 raised to the power what, 9. So if we input everything over here into the calculator, we are going to get 2.25 times 10 raised to the power 6 Newton per Coulomb. So this is our E1, the electric field that the negative is exerting on what, the positive at midway. So let's find E2. So E2 is also going to be the same way, R squared, this times what, 1 over 4 pi E naught. So this is going to be Q, which is what, 2 times 10 raised to the power minus 7. The distance is also what, 2, so 2 times 10 raised to the power minus 2 all squared, multiplied by 4 pi E naught itself, so this is 9 times 10 raised to the power 9. So our E2, if we input it into the calculator, we are going to get 4.50 times 10 raised to the power 6 Newton per Coulomb. Now, like I said, because what, the electric field that is going on around over here, okay, the positive is attracting the negative towards it, and then the direction is like this, okay, they are both going in the same direction, so it's what, constructive. So our total what, intensity, or the electric field intensity, the total will be the sum of what, E1 plus E2. So this implies we have what, our E total to be what, 2.25 times 10 raised to the power 6 plus 4.50 times 10 raised to the power 6. So our E total, okay, if we sum the two of these, we are going to get what, 6.75 times 10 raised to the power what, 6 Newton per Coulomb. So this is how we go around finding the electric field intensity midway for the first part. Now let's quickly do the second part and then we end this tutorial. So just like we did for the first one, the second part is also going to be the same. So let's see. So for II, so the two charge bodies that we have for II are 4 and then 3. So we have, let me rewrite down. So we have the first one is 4, but let me just do this. And then the second one is 4 times 10 raised to the power what, minus 7 coulombs. So they are both positive, as we can see over here. They are both positive. So let me draw that. So positive, positive. Okay, so they are repelling each other. So we have, this is the midway P. So the overall distance from here is 4 centimeters. Okay, but the distance between these two is what, 2 centimeters, 2 centimeters each. And then the charges are what, 3 and then 4 respectively. So let's go ahead and find what the force of attraction between these two. So the force is what, Q1 Q2 over R square times what, 4 pi E naught inverse. Is still the same thing. So our force is equal to what, 4 times 10 raised to the power minus 7, 3 times 10 raised to the power what, minus 7, all over what, 4 times 10 raised to the power minus 2, which is in meters, all squared, multiplied by 9 times 10 raised to the power what, 9. So our force is equal to what, if we input everything here into the calculator, we are going to get 6.75 times 10 raised to the power minus 1 newtons. So this is the force of repulsion between these two positive charges. Now let's tackle the midway aspect of this. So I'm going to say this is E1 and then this is E2, okay, like we did for the first one. So the E1 over here will be what, Q1 over R square multiplied by what, 4 pi E naught inverse. So our E1 is what, 3 times 10 raised to the power minus 7 divided by what, 2 times 10 raised to the power what, minus 2, all squared, times 9 times 10 raised to the power what, 9. So our electric field, okay, that the E1, the positive over here, is exerting on E2, is given to us by what, if we punch this into the calculator, we are going to get 9.0 times 10 raised to the power what, 6 Newton per Coulomb. So our E2 will be equal to what, Q2 over R squared multiplied by what, 4 pi E naught inverse. So our E2 is equal to what, 4 times 10 raised to the power minus 7 divided by what, 2 times 10 raised to the power minus 2 all squared times 9 times 10 raised to the power 9. Now the 2 times 10 raised to the power minus 2 is just converting what, 2 centimeters into what, 2 meters. Okay, so that is how come I'm getting the 2 times 10 raised to the power negative 2. Okay, so it's the conversion from centimeters to meters. I'm not just making that up. All right, so let's continue. The E2, if we punch this into the calculator, we are going to get 6.75 times 10 raised to the power what, minus 6 Newton per Coulomb. Now because these two are acting in the opposite direction, that is, they are repelling each other, our total intensity, okay, at P will be what, the greatest one we have over here is the E1, so it will be what, we will subtract E2 from what, E1. So this implies what, our E total is equal to 9 times 10 raised to the power 6. Oh, sorry, this is supposed to be positive, not negative. This is positive. All right, so we subtract 6.75 times 10 raised to the power 6. So our E total will be equal to what, 2.25 times 10 raised to the power 6 Newton per Coulomb. All right, so thank you so much for watching, and this is how we go around solving questions on what, electric field and then Coulomb's law and then also charge density, which we did not see any example in this case, but still I think with the relation that we showed earlier, you can go ahead and find an example and then solve. So thank you so much for watching, and then I'll see you in the next video. Before you leave, if you are not subscribed to our channel, kindly consider subscribing so that you don't miss any of our latest tutorials. Bye bye.